This is the second video for section 17-3 in accelerated geometry, where we were talking about the unit circle and radian measurement. If you remember in the last video, we went all through the unit circle as to how to find the major coordinates around that circle and what they represent in terms of sine, cosine, and that sort of thing. So today we're going to talk about all of that, but in terms of a different way to measure an angle, which is rather than degrees, we can use radians to measure an angle. Give me a second here. My pen has decided that it does not want to work. There we go. Maybe. Okay. So a radian is a unit of angle measurement that is based on arc length. Remember, an arc is an unbroken part of the circle. So the way it works is if the distance around the unit circle, if that arc measurement is equivalent to the length of the radius of the circle, then the angle measure of that central angle there should be 1 radian. And so if you think about it going all the way around the circle, then if we go 360 full degrees, that is equivalent to 2 pi radians. So 1 full circle is 2 pi radians. And so therefore half the circle is only pi radians. So you're going to need to be able to convert between degrees and radians. And so we use the basic conversion that 1 pi radians is equivalent to 180 degrees. And we can use that relationship to convert any other angle measure. If you're converting from degrees to radians, then you would take whatever your degree measurement is and you would multiply it by pi over 180 degrees. Conversely, if you're given an angle in radians and you're trying to convert it to degrees, then you would multiply your radian measurement by 180 degrees over pi radians. So let's see an example of it here. We want to change 100 degrees into radian measurement in terms of pi. And what that means in terms of pi is that when I'm done, I should have an answer like 2 pi over 3 radians. It should have a pi in the answer when I write it down. So since I'm in degrees, if you can't remember which ratio to multiply by, whether it's 180 over pi or pi over 180, it's kind of like canceling out units in your science class. Your goal is to get rid of the degrees. So right now, I have degrees up in the numerator. So if I multiply by pi over 180 degrees, those degree symbols essentially would cancel each other out. So that fraction becomes 115 pi over 180. That is now the radian measurement. The only thing we want to do at this point is simplify that fraction. You don't want to type pi into your calculator when you're trying to simplify it. You can either try to find a common factor out of 115 and 180 and simplify it that way, or you can just type 115 divided by 180 in your calculator and then do math fraction, and it'll give you the most reduced fraction, which both of those numbers are divisible by 5. So that'll reduce to 23 over 36. And then don't forget that you still have the pi there. So 115 degrees is equivalent to 23 pi over 36 radians. You don't have to write the word radians at the end of it. In fact, if we don't see that and we don't see a little degree symbol, then we assume that that angle measurement is in radians. So now let's try it the other way. What if we're given a radian measurement and we want to convert that to degrees? This is not wanting to work with me today. Come on. Okay, so what if I have negative 7 pi over 8 radians and I want to convert it to degrees? So similarly here, if you can't remember which fraction it is that we multiply by, if you're trying to convert from radians to degrees, the goal is to end up with a degree symbol in your answer. So that would mean that the degree symbol needs to be on top in the ratio that I'm multiplying by. Even more importantly, we don't typically have pi symbols in our angle measures if they're in degrees. So I need my pi to cancel out. which would mean that I need my pi in the fraction that I'm multiplying by to be in the denominator. So when you do that, your pi's are going to cancel, and so the only real math that you have to do is -7 times 180 degrees over 8. And given that this is a degree measurement, you would want to write the decimal if this is not exact, which it's not. So we get -157.5 degrees for the measure of that angle. All right, so I want you to try these two problems now. I want you to pause the video for a minute, and I want you to convert 165 degrees into radian measurement in terms of pi, and then I want you to convert 5 pi over 8 radians into degree measurement. Okay, so in number 3, you should have multiplied by pi over 180 degrees, which will give you the fraction 165 pi over 180, but then 165 pi over 180 will reduce to 11 pi over 12. So your final answer should be 11 pi over 12. And notice I did not write radians at the end, but like I said a minute ago, if it's not written there and we don't see a degree symbol, then we assume that that measurement is in radians. Then for number 4, you should have multiplied by 180 degrees over pi. So your pi's would cancel, and then you would just have to calculate 5 times 180 degrees divided by 8, and you should get 112.5 degrees. And you would want to make sure on there that you put the degree symbol at the end so that I know that you're not talking about radians, but you're talking about degrees. Now, the most common thing that we do with radians is unit circle calculations, sine, cosine, tangent, all that sort of stuff for the angles that are around the unit circle. So I want you to pull out the unit circle that you've been using now since yesterday, or since the last video. Pause the video again, and I want you to go through and I want you to write all of your angle measures around there, starting from 0 all the way back around to 360. I want you to convert all of those to radians. When you come to class tomorrow, it is expected that you have a unit circle with all of your coordinates on it and all of your angle measures in both degrees and radians. So pause the video now and take care of that. Okay, so you'll notice up here that my picture magically changed to a fully complete unit circle in both radians and degrees with all of my coordinates on it. So if you need to pause the video again to check to see if your conversions were right, I would strongly suggest that you do that. Once you've done that, then we're going to talk about how to evaluate some measurements on the unit circle if the angles are given to us in radians rather than degrees. You can use reference angles and the unit circles just like we do with degrees in order to find the trig values for radian measurements. So let's start here with sine of 4 pi over 3. If you go look at your unit circle, 4 pi over 3 is over here in the third quadrant. Look here, it is equivalent to 240 degrees. More importantly, it would have a reference angle. Let me draw in here. If I was to draw in my third quadrant, that was not a good y-axis, but you get the picture. If I was to draw in my third quadrant here, this would be 4 pi over 3. But the angle right here would be 60 degrees, but in radians, that is known as pi over 3. Radians are vastly important, and I'm going to go ahead and tell you guys in a couple of years when you get down to calculus, we don't ever measure anything in degrees. You have to know your radians inside and out by the time you get to calculus. That's why we're starting them now. So finding the sine of 4 pi over 3 is the same as finding the sine of pi over 3, or 60 degrees, except since I'm in the third quadrant, remember my all suckers take calculus. So is sine positive in the third quadrant? No. So I already know that I'm going to get a negative answer for whatever the sine of pi over 3 is, or the sine of 60 degrees. And if you remember, the sine of pi over 3, or 60 degrees, is square root of 3 over 2. So the sine of 4 pi over 3 would be negative square root of 3 over 2, given the quadrant that it's in. So let's try another one here. Tangent of 3 pi over 4. All right, and unit circle in front of you. I'm not going to flip back to it, but if I draw 3 pi over 4, and if you need to, the nice thing about the radians is that you can kind of count fractions. So 1 pi over 4 would be here, a fourth of half my circle. 2 pi over 4 would be a fourth of my whole circle, so 90 degrees. So 3 pi over 4 would be over here in the second quadrant. My pen is really not wanting to work with me today. That is 3 pi over 4. So it's equivalent to 3 quarter-size sections. And if you think about it in terms of degrees, that would be 3 45-degree pieces. So this is equivalent to 135 degrees. But more importantly, its reference angle is 45 degrees, or simply pi over 4. So it's going to have the same tangent as pi over 4, except, think about your sine, all suckers take calculus, so sine is what's positive over there, not tangent. So it's going to be the negative tangent value of pi over 4, which is 1. So the tangent of 3 pi over 4 is equal to 1. All right, I've got some brain teasers here for you. I want you to pause the video and give number 7 and number 8 a try. And I will tell you on both of them, they are more than one rotation around the unit circle. So you're going to have to subtract until you can get them somewhere between 0 and 2 pi. Okay, let's focus just on number 7 here for a minute. If you're trying to get it between 0 and 2 pi, if this was in degrees and it was a really large degree measurement, then we would just subtract 360, subtract 360, subtract 360 to an angle measure that was less than 360 degrees. While in radians, remember the equivalent to 360 degrees is 2 pi. So I need to subtract 2 pi, subtract 2 pi, subtract 2 pi until I get to an angle measure that is less than 2 pi. So in number 7, the denominator of my radian measurement was 6. So the equivalent of 2 pi in 6 is 12 pi over 6. So that's why you see me doing 41 pi over 6 minus 12 pi over 6. So that's like minus 2 pi. And that measurement is still too big, so I subtract another 12 pi. That measurement, 17 pi over 6, is still too big. So I subtract another 12 pi until I get to a numerator that's less than 12. So that would be 5 pi over 6. So that tells me that the cosine of 41 pi over 6 is equivalent to the cosine of 5 pi over 6, because those two angles are at the same location. They are coterminal. Remember that? So then I drew 5 pi over 6, and it falls in the second quadrant. If you count out 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, that's where 5, 6 would fall. But more importantly, its reference angle is pi over 6, because if I'm at 5/6, I would need to add 1/6 to get back to pi, or 180 degrees. So the reference angle is pi over 6. So I need to find the cosine of pi over 6, which I go and look at my unit circle and I realize that it is square root of 3 over 2. So the cosine of 41 pi over 6 is equivalent to the cosine of 5 pi over 6, which is going to equal the negative square root of 3 over 2 because of the quadrant that that angle measure falls into. So let's look at number 8 now. Number 8 is the tangent of 13 pi over 4. So since my denominator was fourths this time, 2 pi would be equivalent to 8 pi over 4. So 13 pi over 4 minus 8 pi over 4 is 5 pi over 4. So 5 pi over 4 is coterminal to 13 pi over 4. So I counted out 1/4, 2/4, 3/4, 4/4, 5/4, and that landed me down here in the third quadrant. with a reference angle back up to the x-axis of 1/4. So tangent of 5 pi over 4 is going to connect to the tangent of pi over 4, which is 1. And so that means that the tangent of 13 pi over 4 is equal to the tangent of 5 pi over 4, which is equal to positive 1, because in my third quadrant down here, tangent remains positive. Okay, I know this can be very overwhelming, so if you'll notice on the next slide, you have very nice, simple step 1, step 2, step 3 for how to find trig functions with given reference angles. These 3 steps will apply for whether it is in radians or it is in degrees. Okay, I would keep these directions handy if you're not sure how to find those values on the unit circle. And then the last thing that we're going to talk about today is arc length. For a circle of radius r, the arc length intercepted by a central angle that is measured in radians. That is hugely, hugely, hugely important. I'm going to underline it, if my pen will work, in red. The angle has to be measured in radians. If your angle is measured in radians, then you can find the arc length by simply taking the length of the radius times the central angle. That's a whole lot easier than what you did last year when you learned about circles and you had to do this ratio of the arc length to the circumference was equal to the central angle over 360 degrees, and you had to do all this cross multiplying. You can just use S equals R theta as long as theta is in radians. And S there stands for the length of the arc. So for example, if we had a radius of 3 and this angle here was pi over 4 radians, my arc length would be 3 times pi over 4, or 3 pi over 4. So that means if I took a piece of string and ran it along this length S and then laid it up against a ruler, it would be as long as the decimal of 3 pi over 4. Okay, so let's actually put that to use with a word problem now. It says a tire of a car makes 653 complete rotations in 1 minute. The diameter of the tire is 0.65 meters. To the nearest meter, how far does the car travel in 1 second? So I need the arc length, which means that I need to know r and I need to know theta. At this point, I don't know r, I know d. My diameter is 0.65 meters. So if that's 0.65 meters, if you remember, hopefully, the radius is half the diameter. So if we divide 0.65 by 2, my radius is 0.325 meters. And let's keep that entire decimal so that our answer is as precise as possible. So the next thing I need is theta. And it needs to take into consideration that I have done 653 full rotations in a minute. But it's asking about how far the car travels in 1 second. So what I need to do then is take that 603 rotations and say, okay, so in 1 full minute, I can go that many rotations. How much could I go in just a second? Well, we would have to divide that by the amount of seconds there are in a minute. So we would divide it by 60 seconds. And so I'm actually just going to leave that. And that fraction does not reduce at all. If we leave it as a fraction, then that'll keep our answer exact as we go. So that's how many rotations, that's how many rotations per second. So in 1 second, that's how many rotations I've traveled through, which means that my theta is going to be the amount of rotations times how many radians there are in 1 rotation. So in 1 rotation, there are 2 pi radians. So if I multiply that out, ignoring the pi, that becomes 653 pi over 30. And that is way bigger than 2 pi because I'm going more than 1 rotation. That's actually a little more than 20 pi radians there. So it's about a little bit more than 10 rotations in a second. But that doesn't matter. What matters is that I can figure out the distance that that tire travels by taking my radius times my radian measurement for my angle. And if you multiply that out and leave the pi alone, that would be 7.074 pi meters. But are you going to go tell somebody that your car drove 7.074 pi meters? No, you're going to tell them the exact distance it traveled. Nobody measures meters in pi. So you need to multiply that through. And look at the directions. It says to the nearest meter. So 7.04 pi is equivalent to 22.2, or we'll say 22 meters. So if a car is traveling at that rate, it will cover 22 meters in 1 second.